right, but everybody feel free to go over there if you want to see the people on the stage. Okay, well this was our great idea that we had this time, to have a closing session, and what it really is a great opportunity to do two things. One, to revisit the themes that we saw, and I want to hear which ones you picked out, and the other piece of it is just to have a frank and great discussion. I mean, the people up on the stage could answer a lot of questions, and I'm here to make sure nobody gets angry. There you go. So anyway, so I'm Gene Bosman, and I'm president of Cloud Architects in Palo Alto, a market research and consulting firm. Used to be with IDC. I met most of you guys when I was at IDC for 15 years, and before that I was with Computer World. And we have an eminent group. I don't have their full bios, so what I thought is I'd make a quick intro, and then they can add to it when they come up. I guess you might want to come up and give a more thorough discussion if you want.
Well, how do we come up?
Just do a roll call.
Okay, fine.
Yeah.
Well, let me know if I leave you out. We'll lead off with Tom Coughlin, who's president. Who was president of the IEEE 2024 last year. All year he had a great session. Did you have it already?
We had the session yesterday.
I missed it. I must have been doing some other thing. Okay, Tom, he's fantastic, and he's heading Coughlin Associates. We have Willie Nelson of Intel. He's back there. He's not the other Willie Nelson. He's this one. The one who sings.
Great introduction.
No, he's very unique.
She practiced that one.
I know, I haven't used that before. Charles or Chuck Sobey of Channel Science, and he'll tell you more about how I misspelled this. It's okay, carry on, okay. Dave Eggleston, a little bit reluctant to come, but he's here as he said he would be, and that's fantastic. He's with Microchip. He used to live around here, kind of, and then they moved to Texas. Okay. And Leah Shaw, we love her, but turns out she went home. So Leah Shaw, get her on email, I think. Brian Ray, is it Ray? There he is. UCIE and also Intel, I didn't know. Both really. UCIE, you'll explain more about that. Eric Herzog,
Eric didn't make it.
He didn't make it. He was on two other White House. Oh well. And Siamek, how do you say it? Tavaloy. He will tell you all about CXL, the CXL Consortium, OCP, Open Compute Project, and also his role at Samsung. And Jim Handy, this is great. He's got tons of information, and I think I heard it. I heard most of them too. There he is. And myself. Okay, so I think what we're really here to do is to have fun and not beat ourselves up and all that stuff.
We got one.
Wait, you got Roman.
Roman, I had you on here. Wait. I got it. Wait a minute. I put it on here, but I didn't get to the right. I'm so sorry. And I'm so happy he's here. Roman Pletka?
Yes.
Okay, and he really lives in Zurich. He's visiting, but he very kindly came to talk about storage and all that goes into it. I'm sorry, wrong slide. Yeah, and you guys should think in the back of your mind, what would you really like to ask all these folks about the conference? And we're not here to ask about forthcoming products and roadmaps. We're not here to do that. But I think the things we heard about optimization of AI and densities and SSDs versus HDDs, ask away on that, and I'll just be here so that, again, people don't get mad or angry, anything like that. Who wants to go first, Dave?
I guess it's Dave.
Dave, you want to stay? Oh, you can do it from there.
I'll do it for you. Dave has an opinion about everything, is what I heard. Is that true, Willie? I have an opinion about everything. And by the way, I think Tom Coughlin, we have to call him His Eminent Grace. That's how I refer to him as president of all electrical engineers. So thank you, His Eminent Grace, for being here. I think just to kick off, a couple things. I see Jay Kramer had wandered in the back, and I always like to blow Jay Kramer's mind every year by saying it's FMS. The M comes first because memory is more important than storage, which bothers Jay. However, one of the things that made me smile, and thanks to the whole FMS crew for rebranding, a couple of years ago, I smiled every time I heard HBM. And HBM was the talk of the conference. It's really interesting what's going on in DRAM. I think a couple of years ago, the conference, we got a little bit boring because it was just NAND and storage, and we even lost Micron and Samsung as sponsors, and now they're back because there's so much more to talk about. So I'm really excited about where the conference has been and where we're going by adopting a lot of the new stuff that's going on. The track I run is called Other Memory. We incubated in there some of the DRAM discussion, and now Jujen An from IBM is leading that track, and so I'd like to continue to see that grow. So I think that's the thing that I observed here this week that I'm very excited about, the energy around that. Also, thinking about HBF, I really enjoyed the SanDisk announcement. I like to put it in terms of it's a crazy, stupid idea to put a media that perhaps doesn't belong on an interface it doesn't belong on. But why not try? Because even if you think about the history of SanDisk itself, it was the very first one, innovating putting flash on a parallel ATA interface, and that worked out. I mean, that's kind of spawned the whole SSD business, etc. So those are things that I saw that I was pretty excited about. I was particularly happy to see Ilkbahar at the end of the SanDisk one talk about SanDisk bringing innovation back as part of its culture. And I was involved in SanDisk in the very early days, and it's great to see that company rolled back out and really adopt something as crazy stupid that just might work out like HBF. So pretty cool. So I think that's my bit. Let's pass it along.
Great, and very efficient as well.
Thank you.
Okay, yeah.
Yeah.
Thank you. Yeah, my name is Robert Pletka from IBM Research, and I've been really surprised kind of how the FMS changed. It didn't just change the name, and I think it was really the best thing to do to change the name, because bringing memory and storage closer together where we actually need it to do the compute, that's going to be essential. And kind of my key observation is, don't take me wrong, I think FMS has been hijacked by AI. So yeah, that's kind of what it is. The name change that we have actually was the preparation for this, to some sense. Now we see all these large language models, RAG pipelines, and whatever what we have. The increasing amount of data that we have and we have to bring to the compute, to our GPUs, that's extremely challenging. And as Leif mentioned before, HBF, that's really a promising thing. Now, just bringing it closer, having the faster interfaces, is that good enough? That's one question. And I saw some good ideas that have been shown here that go beyond that. One is like, why don't we just try to transfer less data by either compress the data, or we offload some of the AI workload to storage, to memory, and we do it directly in memory. And I think that's kind of a key takeaway I have from this FMS. Another observation I made, which is kind of a bit hidden between the lines, is what I call the renaissance of the small block size, or small sector size. Because a lot of these AI workloads, they have kind of random access patterns, and they actually just need maybe 512 bytes or less, right? But typically, everybody was kind of pushing to transfer 4 kilobyte or even more data, right, to the location where we want to have it. But we actually need less. And that's kind of an interesting avenue that's opening here. Okay, thank you.
I guess I'm next. Okay, so I too am really glad about the name change, and I note that we had Western Digital here, even though they are a hard drive company now. And next year I hope we get companies such as Seagate to be joining us as well, so further expanding our adventure into memory and all types of storage as well. So there's some interesting stuff that I came here. You mentioned the HBF, flash module, high performance, high bandwidth flash modules. I think that's an interesting one. And actually, if I may do, my colleague Jim Handy had a slide this morning he showed in the analyst session.
Stand up, Jim.
That's good. You could maybe comment on this, but so the slide was actually showing the proportion of capital spending to revenue from the big hyperscale companies. and basically it's doubled in the last year or two. That's probably not sustainable unless they make money. So there's two things: either inference is going to come and save the day, or three things: or they're going to cut their spending, or maybe the high bandwidth flash will be a way of augmenting the more expensive DRAM, HBM, and that could maybe be a way that they can continue expanding with less capital expense, but still providing the kind of storage memory required to support these AI workloads. So just an interesting observation of, putting some things together here. Is there's things at this conference that may, that I think have a big impact on AI. So even though we've been hijacked by AI, we still provide value to AI. Thanks.
All right. Great.
All right. Well, others are more qualified to talk about the memory and storage aspects, so I'll say something a little bit different. So, what I think is interesting is the underlying infrastructure technologies that are feeding the innovations. So we know what the usage models, AI, and other things are driving down. But so I'm here on behalf of UCIe, which is a chiplet consortium. On the show floor, you might have seen us alongside other industry standards like PCIe, CXL, and a new UA-Link standard, which I don't know if Willie will mention or not. But so I think that the interesting thing is coming to a place like this, you can see everything from a new technology, being announced and incubated, to products that are maturing, CXLs and a lot of different products that they're being shown. And then, we're still talking about, where PCIe is going to go next and how that might lead to the roadmap. And all that's facilitating AI and the other usage models. So I think that's what's great about being here.
So I guess, do we have enough?
I'll just strangle you with You don't have to move. I was thinking about just talking without it because you can probably hear me without it. But so I've got a few hats here. Gene just mentioned that I'm the other Willie Nelson, and there's a little more to it than that. I'm actually the co-marketing or the marketing co-chair for UA-Link. I was on the CXL marketing as well and technical development. I also represent SNIA for Intel along with Rochelle Olvers and a couple others. And there's a bunch of roles I have, and I'm in Jim Pappas' organization. So our goal is to enable the ecosystems that we need for all the memory and storage that we're talking about. And so I think my takes are, similar. I'm going to say we're thinking about how to incorporate AI into the name of the conference for next year. And I was thinking that we could split AI up and go with FAMIS, and it would be famous. But I think we'll probably stick with FMS. I'm not sure, but my takeaway is I think that last year AI was pretty prevalent. It's pretty much in every track this year as well. It's clear that memory and storage is important, but this year it was really embraced. I think we saw a lot of products that really showed how memory and storage need to be treated differently in the AI environment and how those are being approached. We've already been talking about the HBF and others, but even the whole paradigms and the software behind it on how to store and manage memory and the new protocols such as UA-Link for how to access memory between GPUs and things like that. It's really being embraced. A week ago, SNIA announced the new storage.ai. Trying to embrace that it's a problem that isn't really being addressed by one group, and I think we saw that in a number of different presentations. My other role that I didn't mention is I'm also involved in FMS as the technical program manager, and so I thought I'd point out that I think the quality of the presentations this year was just outstanding. I hope everybody else felt so as well. We ended up having over 100 presentations, more than we could accommodate, so we ended up having to reject quite a few, and so what ended up is what was left was pretty high quality presentations and presenters, and I hope that went over well. And then I think the one other thing I'd like to point out that hasn't been talked about much, and you may not have seen it, we experimented this year with FMS a little bit with a company called Rosie AI, and it was in the AI track in Ballroom A, and it was also in the business track with Gene's. We had a little issue with the display on it in Gene's track, so it wasn't on the screen. In the AI room, it was actually on a separate screen, gave a real-time analysis and breakdown of what was being said, along with the slides that were being shown, to give a little synopsis along with what was being heard. So I personally like closed captioning, And it was even better than that, because it actually kind of summarized what was said. So if I missed a line or I missed a word that the speaker said, it still gave you the synopsis of what the message was.
It understood better than we could.
It did, and without opinion, right? It was from the opinion of the speaker, and it came in and just kind of said what they were going to do. We're looking at, there are reports that come from that. We have the data captured from what we did. We also did it with the keynotes, but we're not sure if those are going to get released out or if we're just going to keep looking at it. It was a new technology. I think it was really successful, and I really liked it personally, but we're going to see what we can do with it and see if we can expand on it more in the future. So if you hadn't seen it, a little plug for rosie.ai. You could go look at their website and see what it's about, but I think it's a beautiful use of AI that really lends itself well with what we're doing at this conference.
And boy, should we note, Rosie has a Z.
Does it?
Does
Yeah.
it?
Oh!
Yes.
All right.
Also, we
Who
want to get people's opinion.
Yeah, we
Yeah.
do want an opinion too. So, you know, if you saw it and liked it, let us know. If you saw it, didn't like it, let us know. And if you didn't see it, let us know.
Why don't you ask right now what people thought?
Yeah, that's a great idea,
Oh,
Brad.
great idea, Brad.
So, did anybody here see it? Anybody experience it? Excellent. Did anybody not like it? That says a lot right there. So, if you didn't, we'll...
Wait.
The text could have been bigger in the back of the room.
Bigger font.
Yeah.
Okay.
You could see
Yeah,
it
we
from
were thinking
in
at the
back.
keynotes, it might have been neat for the end screens maybe to have it. For the people in the corners, you could do it, but we decided not to display it real
Willie,
time at the
in
keynote.
this room, right there could be a screen up high enough. Not so much the font as how high the screen is.
Yeah, in the AI room, it was in the middle of the room between the speaker and the
Yes,
screen.
yeah,
I think it
yeah.
worked pretty well there as well, but it was a little low. So anyway,
Just a little comment with regard to that. I had somewhat mixed feelings about it because I'd read it and I'd hear about what I just heard about. And usually it was redundant. I mean, sometimes that's good, and I don't know, there's pros and cons, obviously.
Yeah,
but it's sort of not old news, but it's like a little bit distracting from the current speaker.
Yeah.
Current words, but whatever. Anyway, pros
I
and cons.
appreciate that, and I'll
Yeah.
give one other aspect of it. That, like I said, I'm not sure if we're going to release them or not to attendees. I think we will
Release
for the
it.
sessions. We're going to release the
Release the stuff, because it goes good with the slides.
Yeah, and that's just it. Is I know a lot of people in the past, if they missed a session, they download it, and you'd have to watch the whole, or look through the slides and try to interpret them yourselves. Well, with this, it gives a summary of what the speaker was saying, and so I think it'll really enhance that data afterwards. And so we're looking to do that. We just we have to make sure that we're getting the reports back, and we're going to make decisions on it.
Well,
as it
at least release it to the speakers so they can improve their slides.
That's actually what we're doing first. I wasn't going into details, but they have to say we agree with that, summarize what I said, because we all know that AI occasionally makes a little
Mistake.
mistake.
Sometimes. Sorry, yeah.
Anyway, that's what I got.
right here. So, next row, oh my goodness, they're
Maybe we
trading
should move on to
seats.
first
Oh, see there?
Move up.
It's musical chairs, literally.
This is very
Awesome.
fun. We can do
I'm-
it differently next time.
Siamak Tavalai.
Wow.
So-
Troublemaker. He's great.
Wonderful, wonderful conversation about how FMS actually runs.
Wait, louder?
I'm Siamak Tavalai. I'm a system architect with Samsung now, but perhaps you guys have seen me more active when I was the president of CXR Consortium. I'm also very active with OCP, Open Compute Project Community. That's where we bring technologies into practice with working with a number of colleagues and suppliers and end user customers. That's a very vibrant community. The latest efforts we are having is around composable memory systems that should be a nice affinity with the future of memory and technology and storage that we are here. But bringing us a little bit an intersection of technology, ecosystem, friendliness, and business makes sense to make these comments. Several years ago, when we presented the newest wonderful interconnect technology called CXL, people thought that we're presenting it at FMS at the time as a means to use or buy less memory. It was presented as a tool to reduce TCO because memory was very expensive, and they said, well, let's use this one to use it for less
memory. That didn't happen. What happened instead was people learned ways to take advantage of the memory that they had already bought and better utilization and increase the performance value of their GPUs, their CPUs and such. So that was a very nice outcome. This year, what I learned was a little bit more insightful, I think. What I learned was a lot of these AI ML that we are all trying to serve, they're asking for more and more things. They get more GPUs, more compute elements, but they also now need more memory, because the more we provide space for placing data, the compute can grow and make it even more valuable. So they want a lot of memory, but they don't have it. Not that they want to pay less, it just physically doesn't fit. Because of that, they are using storage elements, SSDs and such, to store or posit memory. Not store for persistent store, but just for local ephemeral storage during the time that they're executing on it. So that's what they have to do. But what happens is that the business people who are selling these things see that people are looking for dollar per gigabyte for storage is much, much, much smaller than the dollar per gigabyte for DRAM or memory. So what happens? Gold data, something that's not really exciting, morbid, goes far, goes into storage elements. And for that, people don't want to pay. It's just morbid, it's not exciting. Whereas the hot data, hot, kind of nice and exciting data, wants to be closer to the compute element, and for that people are willing to pay a lot. So interconnect technologies that allow the community of AI, ML, databases and such to bring storage or space for positing data closer and closer and make it hotter and hotter to the compute elements are willing to use DRAM, memory, in larger quantities if possible, as compared to the storage elements that are not as expensive. They're willing to do that. It's just we as a community need to enable that. And interconnect technologies such as CXL, UA-Link, NVLink, and UEC and others are trying to do that. So once we do that, hopefully people get richer.
Hey everybody, I'm Chuck Sobey. Wanted to talk to you just for Roman. So we had the mention of AI is everywhere, and the way I look at it is a bit different. If you think of some of the technology changes that we've had, like the .com, everybody was a something.com for a while, and then that's gone. And I was guilty of that too. My first company's name was channelscience.com, so I finally got rid of the .com. And then we saw a shrink in technology, and so everybody was nano this and nano that. And you don't see that anymore. And then you see e-commerce and e-this and e-that and the iPhone, right? So AI is going to be just the same thing. It's going to just be. And so the way I look at it is it's innovation. In fact, my new role at FMS is I'm innovation ambassador. So I'm looking down the road to see what we need to be covering. And I'm also the professional development chair. So we do tutorials. So what does the industry need to know in order to accommodate these new innovations? And so what innovation comes down to is change. And so what I'm seeing at this conference out of all the AI distillation is after decades of having a certain architecture in mind for delivering data to CPUs and the workloads associated with that, we're now delivering data to GPUs and the workloads associated with that. And so we're rethinking that. And we've got a chance to, the Blackwell GPU can take whatever we can give it. We are limiting its capabilities. And that's in terms of power and getting data to it. So everything you do to make power efficient products that deliver more data will be used. Inference is where the money is. Jensen Huang from NVIDIA, I don't have to tell you who he is, he talks about the GPUs being factories, the data centers being factories. And what are they making? They're making tokens. Tokens to answer inference. Anytime those GPUs are not providing tokens, they're not making money for the people that invested in them. So fixing those things is kind of our responsibility, where we need to go. And that's where this idea of re-architecting. I'm seeing things like mixing new memory hierarchies. In fact, I'm really excited about the idea of memory hierarchies for specific tasks that are formed inside of a chiplet package. So you can be mixing memories, as was mentioned earlier. FMS now means something different, and it's really prescient because it's the storage and memory getting together and trading jobs. The reason to be more efficient, to deliver more data faster with lower power. And so we're seeing a mix of NAND and DRAM and then other emerging memories. Shortly after Intel had to abandon the Optane phase change memory, the next year I held a session called What's the Difference Between a Memory Chip and a Memory Chiplet? Because what I felt was, how could any emerging memory ever succeed if the might of Intel could not succeed in that emerging memory? And to me the answer was targeted specific chiplets of these emerging memories. And so some interesting things have developed here. One is we're trying to form there's a group trying to form a new emerging memory alliance to try to support that. We've seen Atomic Ethernet pop up, and then in our cold data track, we're talking about archives, and we're putting together a new team because one of the projects I've got, please ask me about my legacy tape project, is we're looking back 30, 40, 50 years to irreproducible scientific data, and we're recovering that data. And the reason is because we can now feed it to AI to improve models. And so what enables us to look back and decode those data is key for what we need in our new archiving technologies that we're making now, like Terabyte, DNA, Silica. Well, when it's 50 or 100 years in the future and there's a bunch of those sitting on a shelf somewhere, who's going to do what I'm doing now and try to figure out how to decode them? So we want to put some breadcrumbs out there now so that the people in the future will have a chance of that. And these are some of the innovations that are coming, and you can trace every one of them back to AI, but it's just change with data. So there's a lot more I can say, but that's enough. Let's watch for 3D DRAM, okay? Keep an eye on it.
So I'm Jim Handy, I'm the last guy. And all of these guys pretty much said anything that I would say. There's been an awful lot of AI here. What's interesting to me is the quick transition that we made from everybody talking about CXL to everybody talking about AI. But something else that I noticed that was a big trend here at the show was that all the keynoters use the word unprecedented. It's unprecedented how often I heard that. It's become an interesting part of our vocabulary, I guess. It's certainly cool to come to a show like this, though, and see all the new things that everybody comes up with. It gives you just incredible faith in human ingenuity and how we're able to come up with things, how we're able to overcome problems that, before would have just been seen as unsurmountable. And, every year I look forward to just being able to get that. So, that's short and sweet. That's my take on the show.
So I have a question for Jim Handy and then also for Chuck. No, but hang on just a second so you can
If
respond.
Dave's asking a question, I gotta go.
Good
seeing you all.
Thank you. Aren't we just, in memory and storage, aren't we just shoving ourselves around inside the von Neumann box?
Yes.
I have not seen anything at the show. So innovation, Chuck, I have not seen much of anything to break outside the box.
Neumann, you must have missed it. We had some.
Yeah, no, there are all kinds of non-von Neumann things. Something that was a part of two of my presentations was analog neural networks.
Yes.
And how they were
Totally
commercialized
agree
by
with that.
Intel in 1989, and how they never went anywhere. So
It was the earthquake.
Oh, I see. Yes.
It's just a joke.
Yes, I think we're being videotaped, but I'm not sure.
But I think as we look forward in innovations, that's why we need to recognize that a lot of what we're talking about here is just, again, shoving around inside the von Neumann box. Let's get outside of that.
Yeah, and there's and one of the things that's going to happen as AI becomes cheap which it doesn't even look like that's possible now. But when AI becomes cheap, and it will end up becoming a part of the the endpoints, the edge of the internet, and that will be not only to reduce the amount of communication that needs to go back, and not only to reduce the latency of being able to get AI to process the data, but it's just going to become a commonplace thing that will solve problems through all of these endpoints.
I like the philosophical thing. Can I say something?
No.
No.
You've got a microphone.
I want this
I'm not
microphone.
going to talk
All
about
right,
it.
fine. Thank you. It works really well. What I want to say is that I'm feeling a little bit of, I used to work for Computer World. We started, in the 80s, more or less. And what I'm amazed about, personally, is walking around either the exhibit floor or talking to people. Things have happened now that we couldn't do before. That we have new material science. We're able to put things closer together, the faster speeds, better interconnects, and these elements were foreseen by designers, but they couldn't do it. And I think we're lucky to be living in a time when we can talk about triplets, for example. So just wanted to make note of that. I think someone wants to start the questions. Should I let him do it?
You're in charge.
I am. Temporarily. Okay,
You've got
right.
double microphones. That's
Yeah,
right.
I'm ready.
Jeez.
I'm ready. So just, I would say in the Q&A, let's do it, but everybody, a couple things. Introduce yourself, your name, your company, and if I decide that you're not asking a question, I'll say it. So please do.
Hi, I'm Rick Fedek, Data Confidential. Here's the question.
Okay.
It's a thought question. There's a book I'm sure you've all read, Innovator's Dilemma, an Innovator's Solution.
By?
Oh, Christensen.
Clayton.
Yeah, it doesn't matter.
The late.
And the basic premise of the book, of course, was that we get to certain things that are so good that the end consumer doesn't care about additional improvement. I'm using a 5-year-old cell phone. I see no reason to go buy a newer one. The question is, at what point do the data centers, do the AI systems become good enough for most consumers that there's no longer pressure to make them better? Maybe faster and cheaper, but not better.
Teacher.
Who's going to try that? Who wants to answer?
Jim Handy.
Yeah, that happened with pocket calculators.
Yeah.
Nobody wanted a pocket calculator that did anything more than what a pocket calculator did. And as the transistors shrunk, just like you said, the prices went down and they ended up becoming giveaways at trade shows. And then they stopped being giveaways at trade shows because nobody valued them even after that. Sometimes the industry calls shots and says, hey, this is going to happen, and they're right. I'm not sure anybody did it with that. And as a matter of fact, at the same time electronic watches came out, Intel got out of the electronic watch business when they found out that the case was more expensive than the chip. So, that was Micronics, I think it was. But we look at things like when SanDisk was only selling a replacement for film in their cameras, they were terrified of what they called megapixel stagnation. And that was once the number of megapixels in the camera got up to 2.5, nobody was going to want to have any higher resolution of the camera because it was going to equal the resolution of Kodachrome, which was the highest resolution film you could buy. And that never happened. So, we're probably going to have things like that. Some of these things are going to stagnate like pocket calculators did. Some are not going to stagnate like megapixels have. And, there's really no way that we can tell right now which is
What
going to
about
do
the
that.
guys who said there would be...
He's got his hand up,
What
teacher.
about hold on. What about, I'm in your turn. What about the guys who said that there would be no need for Xerox machines? And somebody said that. So there is always...
They're all dead.
They're dead.
Yeah, they're dead.
All right, these guys are going to step over me. Please, continue.
Okay, my friend, I have a very simple answer for you. The answer is never. I'm going to explain. Well, we are humans. We've been here for many, many years. Our brain cells have been grown and evolved to where we are. We can imagine things that don't exist yet. And when we can touch, when we can see the things that do exist, we can imagine what we can do with them. Now, as examples, we are talking about AI. We are talking about artificial some intelligence. I have the best model for intelligence right around here. We are people. If I'm trying to find the best friend, if I'm trying to find the best mentor, if I'm trying to find the best leader, once I find him or her, I see that I want more. My friend, sometimes it tells good jokes, sometimes not. I want better jokes. Sometimes they make some witty comments. Sometimes I don't like that. So I want something better. So, because the best intelligence that I can think about is not done, it's not complete, any kind of compute element that tries to even emulate that will not be done. So we will want more. So anytime that you say when, the answer is never.
I got one other on that. It's the comment that I like your example that you've got a phone that you've had for 5 years and you don't see a reason for a new one. I had a phone with a 30-foot cord in my kitchen for a long time that I thought was just great. And so until we know where it goes, I don't think we can ever say that we're done, right? Because I don't know what I'm missing out on. I didn't know I needed a computer in my pocket, but I have one and I like it, right? So I think the answer, and I think a lot of what we do here in innovation, in next gen, in solving problems that we didn't have 5 years ago, is that we're addressing those things as they come up to open new doors that we didn't know we wanted. So I think there are lulls. There are times when it's like, you know what, that 5-year-old phone is pretty good. But the one that we're going to have in 5 years might be like, how did I live without this?
So my interpretation, by the way, of Christian's book, the thing I thought was of value is your future customers, your current customers do not know what your future customers need.
Yes, true.
And so therefore they will mislead you, and that's the problem you run into, is that if you talk to people buying your stuff now, the thing that's going to replace you, they're not necessarily going to be able to give you comments about it until it's too late.
I think the other thing to add beyond CMAC was coming at it more from the theoretical point of view. I think there's an economic point of view, which Mr. Jim Handy has pointed out, which is the AI spending, the AI arms race is going on right now at a 2x spend, twice as much as the typical spend. That cannot continue forever. So I think back to Willie's point, that's going to lead us to a lull. There's going to be a time, I've been saying, when the CFO at all these companies says, wait a minute, what are we getting from all this spending? Where's the revenue that's getting generated out of all this AI arms race spending? So that moment is coming. It hasn't come yet. I thought it would have come by now, but we haven't seen it yet. Jim, I'd like to hear your response to that.
Yeah. Oh, so those of you who didn't see it, there was a slide that I presented in a couple of different sessions where it just showed AI spending by the hyperscale companies. There's like Azure, Amazon, Alibaba, can't remember who else, but anybody whose numbers I could get. And it just showed that back for the past, 6 years, the number has been going on around. The number's been going on around 12% to 15% of revenues. Capital spending has been that, and then it just recently, in the past 3 quarters, it's zoomed up to 25% of revenues. And that, I don't think that that's sustainable. Now, these companies may be deluding themselves into thinking that if they lay off their entire staff and have AI do all the tasks, then they can make up for the money that they spend on that stuff. But I have my doubts.
And I'd like to add though that in the conference proceedings, because those were some great slides that Jim had and other people had, the conference proceedings will have all the slides. It may take a few days, but you will be able to see all the stuff. So I get that question a lot. They will be in the conference. What was that?
More like months.
Yeah.
Depends who's
Yeah.
doing
Not
it.
days, it's more like months.
Oh, okay. Because I could change it tonight. Some of them. I could change this tonight. So, thank you for reminding me. Go ahead.
Yeah, so Clayton Christensen's book is quite important in my industry that I came out of, which was hard disk drive. And we had a front row seat at Applied Magnetics because we were supplying heads to the entire industry. And we saw which ones were stagnating and which ones were coming up, which was the whole fundamental piece of it. And it was smaller drives. You know, as Tom said, one of the key things with the book is your current customers can't tell you what the new markets are.
What's going to replace?
And they said, no, we like these big, 14-inch drives. But other manufacturers kind of wanted smaller ones. And so one of the things that I look at to see, where a technology is going, is the solution something that's stagnant, or is the solution something that's changing? And so, Jim's example of a calculator, of a fixed number of things, that's stagnant. And so it doesn't benefit from scale. It doesn't benefit from growth. And then a watch, the same thing. So where did these go? They got subsumed into a smarter system, into your phone. And a computer subsumed the typewriter, right? Because it was a fixed function. But when we look down at storage and memory, that's not a fixed function. Growth is good, speed is good. And so that would be my answer back to you, Rick, is it static that the goal is, or is it a moving target? If it's a moving target, we're really good at it.
It's a moving target today of features. 3 or 4 years from now, I think we may have to hunt for new features, or we pick the
That's what we look for.
Yeah.
That's what we look for.
Sometimes
Wait a minute,
the
people,
future is the
guys,
past.
One at a time. You're at the mic, you talk.
Thank you.
Okay.
Sometimes the past is the future. And an example that was shown here is, we all know that U.2 is dead. It's been replaced by EDSFF. And what was every high capacity device shown here in?
There were some others, but a lot of U.2s.
Yeah. A lot of U.2.
Well,
It comes back.
thanks for your question. Are there other questions over here?
Okay.
Come there.
All right.
Okay.
Let me ask something different.
Oh, you should talk right to
Oh,
this part of the mic.
Let me say something different. I hope I don't offend anyone.
Identify yourself.
Oh,
George Chen. I worked many years at IBM, and both in chips, bipolar, master slides, enterprise, data arrays, also in storage, DASI, all that stuff. Okay, and then I hate to say this, but you guys are full of crap. The reason is because but let me be technical here. The reason is because if you look back in this area, people are obsessed with these concepts of productization, monetization, and that's not what engineers are for. That's for people who are trying to make money, right? And then you look at this, and as I go around, and I'm saying, is this exciting? Is this innovative? Is this new? No. Why? Because you're missing a couple important things. One is what I would call sparse computing. In other words, if you use 1 million pieces of data to give me 2, I'm not impressed. You know what I'm saying? So a lot of what people call AI is self-circular. It's a circular reasoning. Give me the answer, give me the question, I'll give you an answer back. So the trick is you have to answer things that have not been asked yet.
I totally agree. Hold on.
Right, so that's the way. That's one thing.
Christensen said it's the underserved.
Right,
It's
that's the second thing.
Yeah.
We're falling into this big rabbit hole that everything is digital. The world is analog, man. So where's the analog part that's going to contribute to AI? 0. Okay, those are two serious things. Sparse. You got to use less to give me what you have. And you have to use $100 billion, $100,000 machines. I'm not impressed. You know what I'm saying? Because you basically, for example, if you ask kids today, who's George Washington? They'll say things like, well, he was born in this day, he went to this school, he's this tall, but it has nothing to do with what George Washington is. You have to tell me what his ideas are, what he believes in. Wikipedia doesn't have any of this stuff. It's all useless.
Well,
so those are the two things.
Thank you so much. I want to say something. Hold it. I'm going to say something. Thank you. One thing that I've heard, people often in the press particularly refer to AI as a monolithic thing. But of course it's not monolithic. There's AI for this and AI for that, and we did it through ChatGPT, or we did it with a bigger resource. So I think it's very important. I'll make a prediction. over the next 12 months to 24 months, people are going to start talking about AI more specifically. And you're starting to hear in the background, we're not going to boil the ocean. We're not going to use all the data because it's counterproductive. I think it's going to be much more focused than I heard in the sessions as well. Go ahead.
Okay, so George, I'm not sure it totally addresses what you're talking about, but AI doesn't care. It can't care, right?
Right.
And the kind of AI I like to think about is augmented intelligence. That is our intelligence.
Mm-hmm.
You know, we do not remove human agency. You know, using AI to augment our agency without getting rid of our judgment, right? That's kind of the way I think we should be trying to think about how we use this technology.
But can I respond to that? I mean, like, let me ask you, Tom, what is a beautiful sunset? It's not wavelengths, it's not color, it's not how big.
All right, all right.
I thought you were an
All right.
engineer.
I think we
I'm just
touched
kidding.
on that.
Guys, let me just tie something back together.
Yeah.
That, Rick, this is what next innovation brings, is what he's asking for.
Yes.
Right? So that's why we need to
Feel.
keep innovating.
Next.
So, I mean, it's next. We don't have it now. We agree with you. But we don't have the mechanism for that now either. We can't quantify that. We can't reproduce that with a machine. But that's what things are driving to. So that's one of the things that requires us to keep innovating, doing more memory, more storage, more performance, more scale, more data. So I think at some point data gets interpreted, and I think that involvement of humans is in there too. But that's the innovation that we still need to have.
Mr. Chen will do the
Wait,
artificial
we can't.
So
This is what I was afraid of.
So this is perhaps the piece I was referring to. I sounded philosophical, but perhaps this is exactly what it is. I was saying that we are imagining things that do not exist yet. So this actually turns us how to create things that were not there. So if we do that, then artificial intelligence is not, well, maybe it is regurgitating what we do, but we need a new tool that maybe helps us come up with new ideas, present something that 2 + 2, we come up with 6 or 9, but the data that came to us was regurgitated, but it was presented in such a way that inspired something new in us. I don't know where it came from, but I can imagine a lot of things. I went on the show floor, I came up with a lot of good ideas. I'm talking to you guys, right now I'm writing new ideas based on what you're telling me. It is not that I'm regurgitating. You are telling me stuff, and I'm coming up with things that I never thought before.
And then put it in ChatGPT and see what comes
Can
out.
I just, we got to stop. Can I say something? There were a couple guys who know who you are, and to do that, we're just going to try to let some other people ask questions, and we only have another, when we start, another 12 or 15, no, we're keeping it to an hour, so I can't remember. I'm too tired, guys. Were there other comments that you want to make based on what we said, or do we want to ask for another question? Another question. All right, guys. Do we have different questions that you want to ask? We have another 12 minutes. You can ask them anything you want.
At the microphone.
Oh, at the microphone. Yes, that would be helpful. Uh-oh, he's coming. I know him, but the microphone is preferable.
He wants to ask for a bathroom break.
So two thoughts. One is I want to
Your name.
say something to Your name.
Who are you?
Charles Delisio. So I wanted to say something that, and I think Tom will appreciate this. We need to give another plug to IEEE.
Oh, anytime.
And the one thing that if you ask in this room, and how many people are under 30 in this room, is anybody under 30 in this room?
I think there's a couple.
I think there are.
I
Yes.
think there's
Right
Okay, all I'm going to say is, please go talk to Tom. I'm an IEEE member. If you're an IEEE member, join IEEE, please.
Okay.
Because I think it's really important.
Amen.
Okay, that sounds good.
So, okay, now my next thing is, I looked at I love, Jim Handy's a good friend, and you guys do a wonderful job. I love this show. You do a wonderful job of market research, providing some interesting market research and updates. But Jim showed a slide, and I'm kind of going back on something that Dave Eggleston said, is there was a slide that Jim had where he showed DRAM and then HBM. And the only thing that grew DRAM was HBM. And I think if the world craters, and I have a feeling, I don't know, again, raise your hands.
don't you think we're kind of over our skis on AI?
No.
I mean, I think there's, and if that thing craters, you got a problem, you know? And it's not going to be like, oh, everybody's on, you know, HBF, HBM. We're going to sell more flash. We're going to build bigger data centers. All of a sudden, and Jim brought it up too, I think there's a CapEx issue, and Dave said the same thing. Where's the ROI in Gen AI? And if you look and you ask questions, I mean, specific end-use questions, very few people say, I'm really, you know, corporations have said, oh, I've embraced this, and here's a full example of a implemented AI solution in my corporation.
Yeah. Can I answer that a little?
Okay.
Anyhow,
back to IEEE. Please join IEEE. Okay.
I'm going to answer it just a tiny bit with my journalism background, and that is that it depends who you are, right? There are business people who didn't pay a whole lot of attention to every little thing that we did in the last couple of years, and somehow this made sense to them. They saw ChatGPT, like, oh wow, I can use it this way, I can use it that way. I don't think it changes everything in the same way. It depends on your role, it depends on your strategy. But I do think it is helping. It's helping different people in different ways. And I'm not trying to be a Pollyanna here. I just think it depends who you are, how you're going to put it to use. I think it's very powerful myself. I don't know if you agree, sir. Okay. Any other questions?
I'd like to follow up too.
Go ahead. Go ahead.
So you know, I am an AI believer, but I know that it lies to me sometimes too. So I try to keep that balance. It's given me the wrong code. It's given me the wrong answers. It's apologized multiple times for making the same lie. So you know, we have a close relationship. But I've tried to transform my little company into what I call an AI first company, and I can tell you things about that. But one recent data point that I heard that kind of opened my eyes was there's a very large firm, and I cannot remember which one it was, but let's assume it's a Fortune 500 firm. And they combined their IT department with their HR department. So think about that. That says how much they're using AI to run their company.
Because they wanted vicious admins. Oh, sorry.
They would apologize.
Did you want to say something there?
Yeah.
It's okay?
Yeah, sure. Right.
David Chin. So my question is, if you look at today, because of AI, the software service, they're running much cheaper and a shorter time. And if you look at hardware, so it takes a much longer time. It's actually getting longer and more expensive. If you look at it, no, just the 3 nanometer tape out takes like 7 months to even get a silicon from GDS2 to silicon. And so this is like a divergence of those two economies, right? And how we can speed up the hardware acceleration. Because by the time you have a silicon, it's already outdated.
Yeah, it's a good point.
For the market.
It's a good point. I think the way I'd respond to it, you know, looking at it over many decades, I think that hardware tends to be incremental. And we see steady improvement year after year. Software, to me, is codified ideas. And there's a good codified idea like about every decade. And that's when we take a big leap when the hardware has reached a certain level of capability. You know, we're seeing that with AI, that the hardware had to reach a certain level of capability for us to unlock these, and now, you know, now it's that race. Now hardware, again, looks very far behind.
Yeah, because with a new idea like HBF, right? So that's going to take us probably years before you realize.
Correct.
But talk about like SMR for power, it's like takes more than 10 years.
So I understand exactly what you're saying. I mean, we've kind of got that gap again because software's taken, in my opinion, taken that big leap of a codified idea. What will, my opinion, looking back, is we're going to see hardware staircase year after year, getting incrementally better until we unlock a new idea. So I think I understand exactly what you're talking about for the gap, but that's how I see the gap closing over the next decade until we reach the next leap forward.
So I think it's a very interesting observation, and you're right. It takes a lot more work, in a sense, to do hardware than software.
Yeah.
Right. However, I have been hearing about people using AI to improve, for instance, yields in factories and things of that sort. So, in a sense, software also helps with the creation of hardware.
It helps the front end.
Yeah.
But it's hard to help with the back end stuff.
Well,
You're actually building physical stuff.
These are very good observations. I'm going to tag along the business side and expense and money part of it too. You guys know, going from 28 nanometer to 10 to 5 to 3 to 2, the amount of money that goes into developing the chip is getting very big. So it is more than time, and the fact that software comes in to qualify these things, that's a wonderful thing. AI will help do a wonderful thing, but it is an expensive thing. Therefore, we might get to the plateau that we were talking about. You guys were looking for, when does it stop? We can say it stops first at the hardware money and then hardware production. But it will not, again, stop us from thinking. All of these software guys are a lot of thinkers. And what normally happens is, if you give them a new piece of hardware, they think a different way and do it. If you don't give them a new piece of hardware, they use the old piece of hardware in new ways. They put them together in a different way. They ask me to come up with a different interconnect and do 2 at a time, 10 at a time, 15 at a time of the same thing. So you could think that is a new kind of system level hardware, not chip level, but it is going to add new stuff.
By the way, there's another side of this too, which actually came up at the conference. One of the big themes here is also chiplets. Chiplets are a way of turning what used to be ASICs, deconstructing it basically and allowing a new way in which to put together inexpensive parts, or parts made with different kind of processes with different kind of costs, into a package where you can focus on those things. So there are new hardware approaches that are coming. That
it's actually you kind of move the chip apart.
It's new, it's new ways of putting together hardware, ways that maybe get rid of some of the issues we had in the past.
Yeah. I was actually going to elaborate on it a little bit and get Brian up for it because he's representing ECIE. But the other side of that too is that even with, I think the software development is quicker, and I think it goes to what CMAC was saying about using the hardware that we have now in different ways, because if that software development's that fast, it'll find different ways to use what we have. But although this is future of memory and storage, not Flash Memory Summit, but it's about memory and storage, but a lot of what we talked about here is the interconnect. And what's not happening yet, which often happens with new technology and new interconnects, is that we can't fill a pipe right now. So there's one way to fill a UA link pipe right now, which is AI, right? Because it's the only thing moving that data and needing that much data. But there's going to be more as we get, and while that's happening, new hardware is going to be developed so that pipe's even bigger by the time it's needed. So I think the software development always lags a little bit to use the new technology, even though that new hardware technology takes a little longer to develop. So it always tries to fill up, and so it's a constant, sine wave and a cosine wave going back and forth, and that's what I think is happening.
Yeah, so I was writing, using AI to generate the test bench for UA-Link, for example. So I was able to do it, generate the C++ code.
So keep in mind that hardware exists in the physical world. Software is very much virtual.
Yeah.
And that's where it's two different domains.
Yes.
But one example that I just saw so recently was it was assigning AI to design a rocket engine. I don't know if you saw this, but this has come out here in the last few weeks. And it designed a crazy looking rocket engine that works exceptionally well. And they said, look, that took weeks to do what it would have taken us months to years to do otherwise. So back to the fab, back to the physical world, what happens when we say, Applied Materials says, let me apply AI techniques to designing my next deposition equipment. And it might look totally crazy and work much better. So, these are the unexplored opportunities in the physical world of applying that virtual intelligence capability.
I love what you're saying, Dave. It's like, think differently. Sorry. Anybody else? I think we're going to get into the last maybe 5 to 10 minutes of questions, so we should do that.
Bill Gervasi from Monolithic Power Systems. And one of the things that Jim said was really key, and that was unprecedented. And what is unprecedented is that we've all grown up in 7-year S curves, and we're entering a time frame now where we're talking about 18-month S curves. And so I think that's one of the things that we as an industry are going to have to address is this a short-term thing that these 18-month S-curves are going to go away and we go back to something more normal like 7-year S-curves? Or are we entering a domain where we're on a really fast treadmill and we're going to need to react more quickly in the future?
Wow.
For the first time in history, we have scalable human intelligence. So we're not going back.
Yeah.
Oh, I like that. That's it?
That sounds profound. Not sure.
Unprecedented answer.
That's unprecedented.
Oh, no. It's great. All right, last round of questions. Do we have a couple here? And if not, we should sum up, I think. You want to sum up something, Tom?
Do you have questions for each other?
We don't have much time.
I think we're too tired. I know I am. I know I am.
We're down to 3 minutes.
Where'd you get
that cool lanyard?
From Samsung.
Yeah. Tom, seriously, we pull it together.
Pull it together. Okay, so one conference with multiple cool subjects, unprecedented.
That's right.
Liberty and justice for all.
And with next year being the 20th anniversary, we hope you come back here and find out what these participate and help us to further our S-curve.
So throughout the year, they can feedback.
You can feed. Oh yeah, let us know about the events, activities, things that we should be looking at for next year.
Content advisory board or
We have a
See,
content.
I always like,
yes,
I
we do have-
shouldn't say this, but I liken it to the Macy's Day Parade. We finish it, and then we just start the next one. So
we all
so
have
we'll-
inflated egos and
No,
balloons
wait.
floating just like
It was about the planning. It was about- So seriously, I like the idea of giving the continuous feedback to these eminent folks, but also you can do so otherwise and just keep the thoughts coming so that we can make a even better set of questions next year. What do you think?
Work on your next abstract.
Oh, start
yeah.
now.
Yes, so we'll probably have the call for papers open up. I think, Marty, late November?
November 1st.
November 1st, beginning of November. Keep that in mind.
Yep.
We're going to be harsh. We're going to take the best. And I think our deadline is what,
February 19th.
February 19th to get them in. So keep that in mind.
And we are going to create some new categories too, so please check the site. We're going to try and organize the categories a little bit better that fit better with the content from this year. And I think everybody can hear me, but we're going to be rearranging them. So please, think about what's important to you that you'd like to present on, and look for those papers opening up in November.
That sounds great, and that's a good note to end on. Thank you, everyone, for coming. Really appreciate it.